Okay, so next would be about sigma stuff. Sigma is basically this sign. So for example, sigma, the things that we learn about series kan. We got simple special series, and also we got simple special series, and also we can also find some of GP, I think, through this. Was it GP or AP? But whatever. The main part here is we're gonna talk about that special series thing. So this before that, we want to give you a reminder that K, if we don't use n here, we use n. So if we let K equals to 1, and then let's say we have n K, wait, no, K plus 1. What does this mean? So sigma, the way sigma works is, this is the final value, the final value that you will reach. This is your starting point, and this is the general term. So what this means is, you want to try and let K equals 1, and then count up all the way to n, and then add them all together. This thing itself means sum. So so be like 1 plus 1 plus 2 plus 1 plus 3 plus 2 3 plus 1 plus until n plus 1. So yeah, that's how sigma works. A few things that you have to know about sigma is, first of all, if it's k equals to 1 and then n, and then it's a constant here, constant. So what does this mean? This means that 6 will repeat itself a few times, for example, n times. So if 6 repeats itself n times, so it'll be 6 plus 6 plus 6 plus 6 plus 6 plus dot 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 dot. Then it will repeat n times, so it will be 6n. Yeah, so that's the whole thing is 6n. So if the here is constant, then the total value of this is the value times here, n. So if here is 4, then it will be 6 times 4. The next one will be about power. This will be about power. So let's say you have sigma, and then you have 2k, and then n k equals to 1. So this whole thing will equal to 2 1 plus 2 square plus 2 cube plus so on. So note that this is basically a GP, because 2 plus 2 times 2 plus 2 times 2 square, AR square, plus so on. So this is technically a GP. So you can convert this into the GP formula, which is 2 power n minus 1 over 2 minus 1. So that's 1. So this is your answer in the end. So I'll go further, and I will add it in, times it in, so it'll be 2n plus 1 minus 2. And I believe it will be your final answer. I'm pretty sure I'm correct. But the main focus of sigma on this topic is the special series, which is k square and k cube, where k goes up to n and k starts at 1. So yeah, you need to know the general formulas for each of them. The general formula for k is since it starts at 1, so it'll be 1 plus 2 plus 3 plus so on until n. Since this is an AP, the general formula of this will be n plus 1 over 2. For this one, it will be 1 plus 2 square, 1 square plus 2 square plus 3 square plus 4 square plus 5 square. The given formula for this is not an AP nor a GP. The given formula for this is n plus 1, 2n plus 1 over 6. Don't ask me why. There's a proof for it. And then for this one, k cube, it will be n plus 1 over 2 squared. So you need to memorize that for k, if the value involves k, it is n plus 1 over 2. If it's k squared, then it's n plus 1 to n plus 1 over 6. If it's k cubed, then it's n plus 1 over 2 squared. And remember, if it's a constant c, then the value will be nc, n times the constant. Okay, so I believe that's the main part of the topic. So I'll go to this one. Evaluate the following. Now, remember that you mentioned about how k equals to 1 in this case? But in this question, k equals to 26. So how do we know what the total value is if k starts at 26? What we can do is, we can let k start at 1 and then go all the way up to 50. But after we get go all the way up to 50, so until t50, we want to find t26 to t50. So what we can do is, we can do s50 equal minus s25 equals to this thing. So s25 would be k equals to 1 going all the way until 25. Yeah, going all the way until 25 times k cubed, because it's still k cubed. The whole thing is k cubed still. So yeah, since we're trying to find starting from 26 onwards, we want to try and find from 1 to 50 and then deduct 1 to 25, because we want to find only 26 onwards. But yeah, we have to do it like this because we cannot directly start at 20. We can directly start at 26 technically, but if you were to do that, you cannot use the formula. You cannot use this formula because this formula needs you to start at 1. K starts at 1. Yeah, you need, if you want to use this formula, you have to make it start at 1. So that's why we have to minus do 1 to 50 and then minus by 1 to 25. Because even though we have to start at 1, we still don't want to 25, so we have to subtract it out. Okay, the next question. I'm going to minimize this because I have to show this whole part. So this question, sigma 20 n equals 1 n to n minus 3. Now you will think about putting the values in one by one, but that will take forever. So instead, what you should be doing is you want to multiply the whole thing. So n times 2n equals to 2n squared minus 3n. Now, you see here that here is n squared and then here is n. Remember that I talked about this sigma thing? Remember I talked about here? This is the same thing because remember it's n, it's instead of k it's n here. So what's wrong picture? So yeah, instead of k it's n, but it's the same thing. N squared and n starts at 1, ends at 20. So but you might be wondering as well, how about this constant here? How about this minus sign? The truth is I forgot to mention one part. If you have a minus sign here inside the thing, you can separate it so that the minus still exists but outside of both, if you get what I mean. You can take it out, and write it this way. And how about the 2 and the 3? Same thing. So if I want to turn this into let me just change it to pixel. So yeah, if I since here is already, since we know about this n and n squared thing, we can turn it into n plus 1 and 2n plus 1 over 2 over 6 or n plus 1 over 2. But how about the constant here, the 2 and the 3? How do we want to take those out? It's simple. All you have to do is you put it to the side, and then after you find this whole thing, then that baru you multiply by the number, the constant. It's still going to give you the same value. So yeah, it's way easier. Just take out the constant, the 2 or the 3, or the 2 in this case and the 3 here. After that, then you do this part, this sigma part. Multiply, try and find the sum using those formulas that I just gave. And then find the value, which is 5,110. I think there's one more important part that I have to mention, which is these type of questions where it involves you're gonna find sum of n terms of a series that goes like this. You can see that there is a fraction. It's a fraction. So you cannot use the whole n plus 1 times thing because it's a fraction. This whole thing only works if it's in this type of format. Then you can get n squared plus n. So it only works if n squared n are like that. However, there's another way you can do it. So you can see that the pattern here is 1 times 2, 2 times 3, 3 times 4, and whatever. Let's say I don't have this thing. How do I know that it will be 1 over n plus 1? You need this because sometimes they won't give you the thing. So if you don't give you the thing, you need to find what the final term, what the nth term is. So how do I do that? 1, 2, 2, 3, 3, 4. See, it's plus 1. And then this is 1 plus 1, 2 plus 1, and then 3 plus 1. This 1, 2, 3 thing, this is, you can let this become k. Then k goes up by 1 every single time. But this is k plus 1, k plus 1, k plus 1. And hence, you can immediately identify the pattern here. So it will be k plus 1 or n plus 1. Both are applicable. Just make sure that you write your sigma right, which is the constant here, right? K plus 1, and then if you write the k here, then your k has to be at the bottom, and then the n has to be n. But remember, we're talking about fraction here. So how do we make this fraction into a doable sum? So the main thing that there's two ways to do it. One is by doing what's it called again? Partial fraction, or method of differences. Now, when should you use partial fraction? When should you use method of differences? My tip for you will be to use method of differences when there's only 2 terms. Partial fraction works way faster if you're doing like k plus 1, k plus 2, and so on. That would be way easier if you use partial fractions. Because, it will be impossible for you to do method of differences with 3 terms. But if it's 2 terms, you can use method of differences. Now, how do you do partial fraction? How do you do method of differences? Okay, so partial fraction. You know that your fraction is 1 over k plus 1. You want to try and split it into 2 fractions. So we let 1 over k plus 1 be congruent to 1 over k plus 1 over k plus 1. So we want to split up those 2 factors into separate fractions. And then we multiply the whole thing by k plus 1. So after you multiply the whole thing, multiply by k plus 1, then you will get 1 equals is congruent to, or just take it out, just write it equal to k plus 1 plus k. And then wait, my bad. It's not 1 over k plus 1 over k plus 1. It's a over k plus b over k plus 1. If it's you have to refresh your identities. So like if there's 3 fractions, it's c over 2k plus 1. And then you have to also take into consideration what is the factor here. Is it a perfect square? Is it an imperfect quadratic equation which cannot be factorized any further? Is it, and then another one is this thing a whole number or not? Is this thing more can this thing be divided or not? Is this at its simplest form? For more info of that, I think you should go back to uh, what again? Partial fractions. We have to make sure that if that this thing cannot be divided any longer, because sometimes they will give like value over value, and then you have to divide. But I don't think that's coming out in this exam. But one thing that you really have to make sure is you have to write A, B, and C over each of these things, because you want to find what is the value up here. So after that, we will get A, k plus 1 plus bk. So next thing is we want to 1 equals to, oh my god. So yeah, 1 equals to A, k plus 1 plus bk. So what if k equals to, how do we find A and B? If we let k equals to 0, then b times 0 is 0, right? So A, k plus 0 plus 1 equals to 1, so A equals to 1. And then if k equals to minus 1, then minus 1 plus 1 equals to 0, so this is 0. So minus b equals to 1. So b equals to minus 1. And then after that, you write there, after you get the whole thing, hence 1 over k plus 1 is equal to A is 1, so 1 over k. So since it's minus, so minus 1 over k plus 1. Remember that c is still plus, so if you want to make it negative, you want to bring the negative down, so it will be 1 over k minus 1 over k plus 1. And that's how you do it by using partial fractions. But the other method that they use here is method of differences. So how do you use method of differences? First of all, you have to determine first of all, you have to again write down the thing. And then the tip I want to give you is, the tip that the teacher gave me is, you want to try and do bigger factor minus smaller factor. So in this case, the bigger factor is k plus 1, and the smaller factor is k. So method of differences means minus. So you want to try and do k plus 1 minus k over k plus 1. Right. Because technically, k plus 1 minus k still equals to 1, right? So you can write this thing. This is correct, because k plus 1 minus k is still equal to 1. And then after that, you separate it into two separate equations. So k plus 1 over k plus 1 minus k over k plus 1. Why separate? Because you can separate them. If it's like 2 plus x over 5, then you can equal it to 2 over 5 plus x over 5. Same thing with here. And then cut out the common factor. So you will get 1 over k minus 1 over k plus 1. You just need to be careful though, because sometimes you might, instead of 1, you might get 2. But here is 1. So how do you take it out? You do it by multiplying by half. So if here is 2, then you want to do 1 over 2. Then do it by the whole thing. 1 over k plus 1, for example. So yeah, after that, then you multiply 1 by 1, so it's 2k and 2 bracket k plus 1. You will see more questions like that, so that's why I want to recommend you to do it yourself. But yeah, that's the method of differences. If you do not feel safe with method of differences, I prefer then you should do partial fractions. But if you want to save time, then you should do method of differences. So why do you want to do method of differences? Because you want to do method of differences? Because if you were to do a method of differences, you will normally get a plus and then a minus, or a minus and then a plus. This is very important because if you were to find the sum of the whole series, the whole thing, you see that there is a pattern here. So 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4. If you haven't seen it yet, you should look at here, look at here, look at here. you see that minus 1 over 2 plus 1 over 2, this is 0, 0, 0, 0, all the way until here. So the only thing left here is 0, 0. So you only have this and 1 left. So it'll be 1 minus 1 over n plus 1. Then your final answer is n over n plus 1. So yeah, the main tip here is if you have 3 terms, like when there are 3 terms, then it will be like plus and then minus, like that. It's what you do is you let k equals to 1 and then write those down. K equals to 2, write those down. K equals to 3, write those down. And then so on. And then you will realize that there is also a pattern there where it would be great if I could find a question that, oh, here. I didn't realize I have this part. Yeah, but the thing is pretty hard to look at. So let me just see if I can. Let me just look at the question again. Actually, wait, no. I think that one is slightly different. But yeah, there are some questions which have 3 fractions inside here. That one you must use partial fractions, and then after you get the answer, you want to try and do it instead of 2 by 2, you do it 3 by 3. And then what you realize is here is let's say here is a value here, here's a value here, here's a value here. So most of the time, I think every time, if there are 3 values in one line, this whole thing equals to 0. And this whole thing equals to 0. This whole thing is equals to 0. So what you left here is these 3 values, and also the last 3 values here. This is k equals to n, this is k equals to n minus 1. So when you're doing triple, be careful with what values you put in, because some people might assume that you only need this k equals n value, but no, since these 3 are left in front, which include 2 from k equals to 1 and 1 from k equals to 2, then it should also include 2 from k equals to n and 1 from k equals to n minus 1. Because in the triple type of thing, you need 3 to make it 0. So since these are only 2 and this is only 1, they cannot be 0. So you must add them together, or you must subtract them together, depending on what the value is. So yeah, just be careful with